Good morning. And well, it might not be morning when you're listening to this, it's morning when I'm recording it. Hence my deep voice this morning. Anyhow, this is section 1.5. We're going to break it up into two parts. So, this first video will cover solving a quadratic equation by factoring and also introduce the concept of completing the square. The second video will include the quadratic formula and a couple of applications. And so, just to be clear, this first video is going to entail these steps right here. All right. This and this will be in video number 2, and you will not see this at all. All right. We're not going to talk about those steps. And so, if you want to see stuff about the discriminant, that's in your textbook. But we're not going to make specific use of it. Okay, so this is what we'll cover here today in video 1. All right, so remember the quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. A, b, and c are any real number. A is equal to 0. And the reason that we write it like this is called the general form. The reason we write it like this is because almost every time you want to solve a quadratic equation, almost every time, the first step is to set it equal to 0. Now, there is one special case where we don't do that, and we'll talk about that here in a minute. Okay? So, the reason we set it equal to 0 is something called the zero product principle. We spent time in section P5 remembering, recalling, learning how to factor. And the principle of factoring is this, that if a times b is equal to 0, then a equals 0 or b equals 0. There is no other number that has this property. Okay? For example, if you have a times b equal to 4, a does not have to be 4, b does not have to be 4, because a and b could both be 2, and you get 2 times 2 equals 4, and neither of them is 4, right? But sometimes students will forget that, and they'll have a factored thing like x plus 1, x, or x minus 1, x plus 2 equal to 4. And then the next step will be that you set these equal to 4. All right? And that is absolutely not true. Only when you're factored equal to 0 can you break things apart. So basically what I tell students all the time is factored equal to 0 is great. Factored equal to anything else is pointless. And if you have an equation in which you're factored and you're equal to 7 or 4 or 2 or -8, then what you need to do is you need to FOIL out that factoring and then set it equal to 0 and see what you can do. Okay? So factoring is only good if you can set the equation equal to 0, if you're trying to solve it, that is. All right? So to solve by factoring, you set it equal to 0, factor completely, and move through the process. Okay, it's a pretty straightforward process. You can pause and pause the video and write these down if you like. We're just going to do an example. Okay, so we want to solve this by factoring. 2x squared plus x equals 1. And again, it's possible to factor out an x right now. Right now, it is possible to factor out an x. But factored equal to 1 does you absolutely no good. So don't do that. But first, do what? Subtract 1 from both sides and get 2x squared plus x minus 1 equals 0. Okay? And so then the next step is to factor this out. Turns out that it factors to 2x minus 1 and x plus 1. I don't expect you to be able to factor it quite that quickly, but you should be able to do this factoring by now. Okay, this is a process that we, again, are expected to know coming into this class, and we did some stuff in section P5 to help you kind of review that. If you need more help with factoring, let me know, but that's something you got to be able to do. And that's something you got to be able to do throughout this course. All right, so we factor, and then what's the next thing we do? The next thing we do is we say, okay, 2x minus 1 has to be 0, or x plus 1 equals 0. That's the zero product property, that one of these two factors has to be equal to 0 if the product is equal to 0. Okay, so they solve it on the next page here, break it apart, 2x equals 1, so x equals a half, and then x plus 1 equals 0, so x equals -1. So these are your two answers. Usually when you have a quadratic equation, you'll have two answers. In fact, the only time you won't have two answers is if you have the same answer twice, and that's considered a double root, and so it's actually considered two answers as well. But you only have to write it once. And so that's it. So they do a step 5 where they check the answer. All right, again, I'm not worried about you checking your answer. You can certainly check your answer, and it's a good thing to be able to do it. But if you're running out of time, or if you don't write down checking your answer, that's fine. You can do it with your calculator, that kind of stuff. And so that's fine with me. Okay. So if things factor, right? If things factor, then you have a very nice, easy step-by-step process to solve the quadratic equation. Unfortunately, not everything factors. Not all quadratics factor. And so what happens if they don't factor? Well, here's a special case. This is a special case of quadratic equations, and this is when b is equal to 0. Okay, so remember the general form of a quadratic is ax squared plus bx plus c. And so if there's no b, if b is equal to 0, then there's no x term. So if there's no x term, all right, we use what is known as the square root property. And the square root property just basically says, this is the special case, right? This is the time where we do not set this equal to 0, but we isolate the x squared. So we're going to subtract 45 from both sides, and then we're going to divide both sides by 5, and we're going to get x squared equals -9. Now, if x squared equals -9, what can we do? All right, well, there's a square root property that says that if u squared equals d, then u equals the square root of d or negative square root of d. Okay, so basically what's happening here is we're taking the square root of both sides, but when you take the square root of a square, you don't just get the u. You actually get absolute value of u. And so if the absolute value of u is equal to d, then u is equal to the square root of d, or u is equal to the negative square root of d. That's why when you take the square root, you get a plus or minus. And a lot of students forget that plus or minus, but it's because you think that the square root and the square cancel each other, and that's not exactly true. Because again, if u is positive, then they do cancel each other. But if u is a negative number, then you square it, you get a positive number, and it doesn't take you back to the negative, right? And so, right, 3 squared is 9, but -3 squared is also 9. And so there are two numbers that square to give you a 9, and you can't tell which one it is, so you have to take both. Okay, so if we go back to our problem here, then we say we're going to take the square root of both sides right now, and when we do that, we get a plus or minus square root. I'm going to skip the absolute value step, and so I get x equals plus or minus. Remember, pull out the I first, and then the square root of 9 is equal to 3, and so we get plus or minus 3i as our solution set. Okay, two answers again, plus 3i and minus 3i. And that's how you solve using the square root property. Okay? So, we're going to use the square root property in order to come up with a formulaic approach to general quadratic equations. Okay? And that general formula, that general process is called completing the square. So if you want to complete the square, if you have x squared plus bx, then if you add b over 2 squared, then you'll get a perfect square. Okay, so example, if you have x squared plus 6x, okay, and that's equal to 0, then if we take a plus 9, where'd the 9 come from? Take 6 divided by 2, get 3, and then you square it and you get 9. If you add it to one side, you got to add it to the other. Then what happens is this factors into x times x and plus 3 and plus 3. It's a perfect square. And then once you have this perfect square, then we can square root both sides and then solve for x. Okay, so that's the process. Completing the square, if you have a number out front, okay, if you have a number other than 1, you can't do it. And so if you have a number other than 1, you have to divide everything by that number first on both sides of the equation. Okay, I'll show you an example of that. All right, so you want to solve x squared plus 4x minus 1 by completing the square. Again, just like with the other guy, the first step is you're going to have to add 1 to both sides. This is the time where we do not keep it equal to 0 if you're completing a square. This doesn't factor, obviously, so that's why we're completing a square. What do we need to add to both sides? Well, if you take 4 and divide it by 2 and square it, you get 2 squared, which is 4. And so we're going to add 4 to both sides. Okay, we add 4 to both sides. So this gives us x plus 2 times x plus 2. If this does not factor into a perfect square, you did something wrong because we're completing the square. That's the whole point. 1 plus 4 is 5. So we get x plus 2 squared is equal to 5. Okay, so now what do? Now we take the square root of both sides. Using the square root property, we remember that that means we need a plus and a minus square root of 5. Square root squared is x plus 2 equals plus or minus square root of 5, and then we subtract 2 from both sides. So we get x equals negative 2 plus or minus square root of 5. Remember that that means 2 different answers, right? This is x equals negative 2 plus square root of 5, and x equals negative 2 minus square root of 5. All right, so you have 2 answers, and that's the process, okay? And again, if you have, if we want to complete the square here, when you're dealing with something like 2x squared minus 8x plus 7 equal to 0, then the first thing we have to do is divide everything by 2. We got to divide by that a term out front and get x squared minus 4x plus 7 halves. All right, then we subtract 7 halves from both sides. Then we're going to add, well, it's a 4 again, right? The 4, take 4 over 2, square it, and get 2 squared, which is 4, okay, here. So this factors, this time it's an x minus 2 squared. This guy, right, this is negative 7 halves plus 8 halves, so we get 1 half. And then we square root both sides. And you get the same thing. You get x minus 2 equals plus or minus the square root of a half. And so x equals 2 plus or minus the square root of a half. You could rewrite this as the square root of 2 over 2. I don't really care if you do that. You could even make this one big fraction, all right, but any of these answers I would take, okay? I'd be fine with that. So the only difference if you have a number out front that's not a 1 is you have to divide everything by that, both sides, right? Everything gets divided by 2, both sides, but 0 divided by 2 is just 0, okay? So that's the first half of section 5 and 1.5, and the second half video will be available soon. Thanks.